the starting 0. You're not going to be given the starting term when you're going to factor. So you have to be able to decipher what do you start with. Well, it just so happens that there is a rule for this. So what I want to do here is explain to you guys what this rational zero theorem is. You're going to use this over and over. So let's put this away. If you got other questions on it, let's worry about it later. Let's start writing this down. So if I want to look at to find the rational zeros, I want to find all the rationals, which means am I working with imaginary numbers today?
No.
Nope. Not until we get to the part of this with 6.7. That part we'll start to bring back into some of the imaginaries. We'll briefly touch upon that today. So we've got the function x cubed plus 2x squared minus 11x minus 12. It's 4 terms. We would normally think, hey, maybe I can group that. I can't. I won't get common GCFs here. So what we have to use is what's called this rational zero theorem. Yesterday, you guys were given a place to start synthetic division. Today, you have to come up with your own starting point. Well, in order to come up with your starting point, you do this. You take all the factors of the constant divided by all the factors of the leading term coefficient. And you put a plus minus in front of them all. What is the constant of that function? Negative 12. What's the factor of the leading coefficient? 1. So that means all of my possible zeros, this is called listing out, would be all the factors of 12 divided by all the factors of 1. Well, what are your factors of 12? 1, 2, 3, 4, 6, and 12, right? All divided by 1. And it's all plus minus. So that means, how many possible zeros does this function have?
A lot.
A lot, yes. Well, how much is a lot in this case?
6.
12. There are 12 possible zeros to this function, which means we have to just, it's okay. We have to guess or just start somewhere to see if it's a 0. Do you guys remember what it meant to be a 0 when you synthetically divided? What was your last value? 0.
Yeah.
So what we're doing here is a ton of synthetic division. When we're checking these things, let me just put this on a separate sheet here, it's easier. When we're checking these things through to see whether or not something is going to be a 0, just start with 1. Check and see, does 1 synthetically divide into 1, 2, negative 11, and negative 12? Remember, I'm plucking my coefficients. I'm going to use synthetic division. And if you recall, synthetic division is something that we're going to get really good at because it's pretty easy to go through. Remember, drop the first term, multiply, add, multiply, add, multiply, and add. Did that equal 0?
No.
No. So is 1 a 0 for this function?
No.
All right, check negative 1.
Yeah, when all this was just switches.
No. This is the easiest way. This is the only way to do this. No, seriously, it's. I don't know how this can get any easier. No, don't lean back in your chairs. Okay? This is the absolute most simplistic way to set these problems up. Okay? So is negative 1 is my 0. Do you agree?
Right.
Okay. Yeah.
But not all problems are going to have 12 possible zeros, right?
No, they could have 13. They could, what would have 13? They could have 14. They could have 20. They could have 6. They could have 4. They could have 10. Okay. Now what happened? Yeah.
So the remaining number is a multiple of 12 and it's a 0? Or it has to be 0? Like if it,
The last value when you synthetically divide has to be a 0. If that's a 0, then whatever you synthetically divided by is the 0. So this basically says that negative 1 is a 0. So that means my list is negative 1 is a 0. Now, when you synthetically divide, remember, what happens to your degrees here? What is your new degree? It's x squared plus x minus 12. Can you factor that?
Yeah.
What is it?
X
Good. X plus 4, x minus 3, and what are your other zeros?
-4 and 3.
So your other zeros are -4 and 3. Synthetic division allows you to find a place to start. It finds you your first zero. A lot of times it breaks it down into something you can factor right away. Synthetic division is the starting point to allow you to factor at a rate that's easier for you guys. Yeah, go ahead.
So there's no other way other than just guessing, right?
Correct. Just start with one and work your way through it. You'll have to do it a couple of times every once in a while. Okay? Synthetic division allows you to walk through to find zeros. Synthetic division allows you to lower your degree of your polynomial to get to a point where you can factor it quicker. Yes, sir?
More than one word?
Yeah.
Like if -1 goes 0, can 6 also be 1?
It could be, sure. I mean, could I have continued on and checked 2 and checked 3 and checked -2, checked -3 and kept going on this one? Sure. But remember what synthetic division does. It drops it a degree, and always see is x squared plus x minus 12. Is it factorable? If it's factorable, be done with it. It's a fast, quick, efficient way to factor through via synthetic division by listing out your possible zeros. All right? It's the easiest way that I can think of to show you how to factor the largest polynomials. Okay? Again, if I wanted to just list out don't have to write all this out, but what would I be listing out? What's your coefficient on 4? Or excuse me, what is your constant? Be 56. What is your coefficient, your leading coefficient?
1.
So I'd have to list out all of my terms of 56. I was thinking 2 and what would that be? 28. 3 doesn't work. 4 and 14. 5 doesn't work. 6 doesn't work. 7 and 8. And I would be doing that, and they would all be plus or minus all the way across.
That's 20.
What's that? So you'd have to check all of those to find out which one goes with. But remember, you always start at the 1 and work your way through. You might be pleasantly surprised that it's very, very efficient to do this. Remember, when you're listing your zeros, it's the factors of the constant divided by the factors of the leading term coefficient. And then you just pick one and start. I'm glad you asked.
Yeah, I was about to say that'd be really hard.
Of course it will be. Oh,
So you just wait.
maybe put a. You get one that works cleaner. Let's try this one.
So don't. So work on that one right now.
Yeah, let's just like Soda was saying. Our leading term coefficient now is not 1. What is it?
2.
What are all the factors of 2? 1 and 2. So we start again by listing out all the factors of the constant. All the factors of the constant are going to be 1, 2, 4, and 8, right? Divide all those by 1.
By one.
Because what are your factors of 2? 1 and 2.
And then you gotta do it again.
Then you got to do it again. 1 over 2. 2 over 2. 4 over 2. 8 over 2. But again, what happens when you have leading term coefficients that are not equal to 1, you might get some fractional amounts that you've already accounted for. What's 2 divided by 2?
1.
Do I already have a 1 accounted for?
Yeah.
What's 4 over 2? Do I already have a 2 accounted for? What's 8 over 2? Do I already have a 4 accounted for? Again, you can list them all out, but some of them are going to backtrack. So you don't have to worry about synthetically dividing with a half. Not that bad. Okay? So if I want to list out all my possible zeros, I've just done that. If I want to find all of my possible real zeros, I have to use synthetic division again. What number do you want to start synthetically dividing with?
1/2. 1. 1.
Just start with 1 and work your way through it.
Said that they weren't.
Start with 1. I don't want to synthetically divide with a half. The reason is because I have an odd number mixed in
Why
here.
are you starting with 1 though?
Why not?
Because that's everything easier.
I could start at -8 if I wanted to. I'm just starting at 1. All right? So again, synthetic divide, our coefficients were 2, -5, -14, and 8. We'll start with 1. Use it and go. 2, 2, -3. Nope,
Why you put an X?
because it didn't work.
Oh,
-1. You,
just fly on through.
yeah, you guys would fly right through this too if you tried writing it down. Again, use your synthetic division, drop it down. Nope. Go to 2. And just keep working.
But as soon as you get one right, you get the rest right?
You should.
That's every factor, right?
If it's factors, yes.
Who is that?
Why are you putting these?
Nope. Go to -2. See how sometimes you have to do this a few times to get to be able to find it. There's no rhyme or reason.
Yeah, there has to be something in there.
So you're at,
Oh, bam, that's 1.
so -2?
I found a 0 at -2. Okay? I found a 0 at -2, so I start my list. Doesn't really matter where I go. Or I can just circle it, but I know that I have it to go. Now, this new one is 2x squared minus x plus 4. What times what is 8? You add together to get -9. -1 and -8. So I could factor this one from here. This new term is 2x squared minus 9x plus 4. So I could factor that. What times what is 8 to get to the -9? So it's 2x squared minus 8x minus 1x plus 4. And you get to factor out. What are your other two zeros then? 1/2 and 4. So this problem, the answers are -2, 1/2, and 4. Those are your 3 possible zeros. Synthetic division allows you to be able to do that. It takes it down a degree, hopefully to find into something that will be easier to factor. Okay? Now, did I have to stop there at 2x squared minus 9x plus 4? Could I have continued to synthetically divide with my other possible zeros just to keep going? Sure, I can. And you can do that if you're not a person that really enjoys factoring. It's just going to take a little bit longer. That's why we blend all these different possible ways of factoring all together. Yes, sir?
So once we find our 0, we factor that, then we're done.
If it's a degree value that you can factor, yes.
Okay.
Because when we get into a little bit more of this, we're going to have 5th degree, 6th degree polynomials. You have to do this a few times, and you might have some grouping issues and things like that. Okay? There are many possible things that are going on, but it's all the same general principle. You're always going to be listing out your possible zeros. You're always going to be starting with one of them and work your way through it to find the others. Yeah. Yep. If you can, yeah. Yeah, but there'll be times where you might wind up with like an x cubed, an x, and a 4. You can't factor that, but you can continue synthetic division. All right, so there are many different things that are just going to go on here. Which leads us into the other part of this. Instead of just having real answers, we could also have the imaginary answers. We could also have larger polynomials that were doing the same exact process. It just takes a little bit longer to get through. I still ask the same exact question. I still ask, what are all the possible factors of my constant? divided by all my possible factors of my leading term coefficient. Now, with this fundamental theorem of algebra part here, we've been discussing this all along without you guys really knowing that you've been discussing this. What's the degree of this polynomial?
1.
Alright.
5. Remember, the degree is the highest exponent?
Right.
Okay.
Sorry.
So if the degree is 5, how many total possible zeros can we have?
10.
That's in the past. Let's worry about what we're doing, okay? Come on. Worry about what we got going on now. So that means I can have up to 5 total possible zeros. Does that tell you that there are 5 distinct possible zeros? It just says that there can be 5 of them. Does that mean you can have them repeated? You can. Remember, when we've had, we did y equals x squared. There's a parabola. It went through the origin. The 0 was at the origin, right? It only had 1 0. But it was a squared term, which means that 0 is just repeated. This may happen. This may happen quite often. All right? That's what this basically tells you. So again, all of my possible zeros, or excuse me, all my possible factors of 6. Do I need to write divide by 1 on all of those, Katie? Sit up. Write something down. I shouldn't have to explain it to you guys paying attention. This is an honors level course. This is chapter, the end of chapter 6. Work ethic in this class is pretty crummy sometimes. Again, when I'm going to do my synthetic division, do I need to have a placeholder for it?
Yeah.
Where? Good. Just remember that. Sometimes they'll trick you and throw a, where you have to have a placeholder. 1, -2, 0, 8, -13. Yeah, remember you put a placeholder in for any degree that's not
I
there?
thought you meant like the number to the left. I was so confused.
Oh. And again, where do you want to start? 1. Start at 1.
Is it possible that they could just be horrible problems and it ends up being like -6 and +6?
It's possible.
I do.
Well, you'd get better at it if you wrote it down.
Right, I am. Mentally.
Whatever. I don't even know why I bother sometimes. Is it a 0?
Yes.
Yes. Do I now have a new polynomial to work with?
Yeah.
I do. Okay. I know that 1 is a 0. It worked. I know that my degree now is what? It's a 4th degree polynomial. It has 5 terms with it. Do I know how to factor anything that's a 4th degree polynomial that has 5 terms? No. So I'm going to use synthetic division again. Now, since I've already gotten a 0 here, I'm just going to back that off. And again, I ask the question, I'm working with the factored forms. I have a coefficient, excuse me, a constant. I always call it a coefficient. I have a constant again of a 6, even though it's negative. What are all your factors of 6 again? 1, 2, 3, 6, right? So it was plus minus, very good. So again, it just so happens that I've got the same values I started from before. So I have to start again with 1 to see if it works on this next one. What this is catching is if this 1 is a repeated value. Okay? Let me explain that further here in a second. Andy.
So we take the equation of the way if it was regular factor again, the equation
Yeah, it just so happens in this case it's the same terms. Okay? Now, what this is telling me right now is, let me put this on the other screen, is that right now I have x minus 1 times the quantity x to the 4th minus x cubed minus x squared plus 7x minus 6. I have that right now as the factored form of the x to the 5th minus 2x to the 4th plus 8x squared minus 13x plus 6. I have basically factored out an x minus 1 by using synthetic division. I'm going to continue to try and factor out this stuff by using the same means, by using synthetic division again. It just so happened, like Daisy said, that my constant is the same one as we had before, so all of my possible zeros are 1, 2, 3, and 6, plus or minus. So again, start at 1. Synthetically divide. 1, 1, 0, 0, negative 1, negative 1, 6, 6. Oh, look at that, we got another 0.
So it's repeating.
So it's repeated. So now, again, I have an x minus 1, x minus 1, and now my new polynomial is x cubed minus x plus 6. And this is kind of what you were saying earlier, how I have that I can't factor the 3 terms, but what can I do again?
So you're just continuing.
I'm just continuing with synthetic division.
terms.
Yep, I keep going. I keep going. Again, since this wound up being a 0 here, can I just use the same spot?
Yeah.
Lo and behold, we got lucky again. It's still the last term is a 6. I know all of my possible factors of 6 are 1, 2, 3, and 6. So, let's try a 1 again. You never know.
Oh my goodness.
This is good.
Nope, didn't work. So, try negative 1. Remember, you're using that value right now. Try negative 1. Nope.
Oh, no.
Try 2.
Got my money in too.
It's right. You laughed.
Hey! Negative 2 worked. If negative 2 is a 0, what's your term?
2. Or x minus 2.
No,
X
negative
plus
2. Or x plus 2 is your. I'm sorry, I did say that wrong. I said negative 2. I meant if
Wait.
positive 2 is the 0,
Yeah.
your term is x minus 2.
Wait.
What?
No,
It
that's
doesn't
wrong.
work.
No.
This one is 3, not
Negative 1 plus 1.
Oh, I was thinking it was. I knew the answer was negative 2, so I did negative 2 in my head.
Oh.
All right. So 2 didn't work, right?
So I wonder if it works now.
Hold on. Wait a second. Hold on. Don't mind me. Pay no attention, man behind the curtain. All right. So we had 2 didn't work, right?
No.
Okay. So let's try negative 2.
It works.
Negative 2 works.
That's not
Math is hard. Okay. Negative 2 worked. Sorry. So now we have x minus 1, x minus 1, x plus 2, and my new one is x squared minus 2x plus 3.
Oh, you have to continue.
What times what's positive 3 that adds together to get negative 2? Negative 3 and negative 1,
No, I said negative 3.
that would give me a negative 3 at the end.
Oh,
I can't factor that, so what's the next easiest way to factor?
Show us again.
Synthetic division.
Well, we can synthetically divide, but if it's not going to be a factorable term, synthetic division isn't going to work, is it?
Divide.
Quadratic formula.
Quadratic.
I knew you were going to say that.
Oh, you mind?
That's a long problem.
Didn't you just plug in the x's?
So, opposite of b plus or minus square root of 4 minus 4 times 1 times 3.
It's like the longest math.
All over 2. Now, take a look at what happens here. Your discriminant's going to be negative, isn't it?
Yeah, so
So,
So you're going to have an imaginary solution at the end. You cannot use synthetic division to get to an imaginary solution. But it broke it down to where you got to the point of being able to get there. 4 minus 12 is how much?
negative 8. Negative.
Negative 8. What's the square root of negative 8?
2i root 2.
2i root 2. So right now we have 2 plus or minus 2i root 2 over 2.
This is 1.
Good. So my final solution here My 5 possible zeros are
It's so clean cut. It's like
1,
I understood the
1,
first part.
-2, and 1 plus or minus I root 2.
I just actually
Synthetically divide all the way down till you get to the quadratic.
Right anymore.
Try to factor it. If you can't factor it, use quadratic formula. And it'll give you a possible imaginary solution. It's synthetic division all the way down until you get to the quadratic, and then when you get to quadratic, use quadratic formula and go off that.
Wait, are there gonna be problems where you can just factor it though?
Oh yeah, there will be. I'm just showing you, I wanted to show you the worst of the wear to get, to say the least, okay? Yeah, pretty much. Pretty much. And then what we'll do tomorrow with this is we'll continue some more of these tomorrow, but we're also going to work backwards. Yes, sir?
Will we have any this long on the test?
Or
That'll be it.
When you think about the test, if I do something like this, how many of these can I have you do?
One.
Yeah.
So don't do it. Or have it a 3
Oh, I got my mom's on speaker. Don't trust me. You talk to people like, what?
10 minutes? That's not gonna be a turned out.
Oh wait, this was 22, 24.
43, 50.
I'm gonna even do those. Sorry.
Oh, that's even.
Yeah.
Oh, shoot.
The 6.6 stuff, you're not going to have any imaginary stuff to worry about. They're asking you to find reals. It's going to be relatively straightforward.
So
The 6, 7 are the ones that are a little bit longer, and it's impossible to get an imaginary.
But there's only 2 questions.
Just start with the 6, 7. Tomorrow, we're going to work backwards out of this stuff. Tomorrow, I'm going to give you the zeros. You're going to tell me the functions. But you've been doing that. If I tell you your 0 is at 3, what's your term?
Negative.
X minus 3. If I tell you your terms are 3 and -5, your terms would have been x minus 3, x plus 5. Foil it out, there's your polynomial. Yeah, there should be one hiding around here somewhere. Here. What's that sound? Okay?
So I don't even know what is that? That's the first time I heard that.